What's up, Canosa?
What's up?
How you doing this morning?
Tired.
Why? We just had a weekend.
I just woke up from being at my friend's house. It's fine.
Well, good. I'm glad you made it. See, everybody's muted as they come in. How's it going, everyone?
Good.
Good.
Excellent. So did anybody have any, let me tell you about my weekend while we wait on others. So we went up to, for my birthday, we went up to Amanicola. You ever heard of that? Amanicola? I don't know how to say it. Anyway, it's a state park up in North Georgia. Beautiful waterfall, a lot of hiking. So I am extremely sore today. And I busted my fanny trying to walk along the creek and make sure my son doesn't fall in the water. So I about completely went headfirst into a creek. But I saved myself. But everybody saw me. So it was pretty embarrassing. But we had a good time.
When was your birthday?
Friday.
Mm.
It was Friday.
Happy birthday.
Thank you. Anybody else have a good weekend? Nothing exciting? Everybody corona free?
Yes.
Yeah.
Man, only 7 people. Where is everybody at for a Monday morning? Actually, only 6 people. So today I was actually going to just do a lesson. And if you don't mind, so I'm going to share my PowerPoint screen. And we'll just actually go through Keeper, I think that's 29 maybe, or 28, I'm not sure. And there's only 10 slides. It's Keeper 29. So, and then I'll post this on the blog. So that way we have it. Does anybody, though, before we begin, did everybody get a chance to see blog 20 or Keeper 28?
Yeah.
Was there any questions? Huh?
So basically, you just have to graph it.
Well, what we were learning in 28, it's called transformations. And we just wanted to know, are we moving left, right? Are we moving up, down? And what is the vertex? Today we're actually going to be plotting those. And so you'll kind of get a refresher on 28 as we go through 29. So let me share my screen real quick and we'll begin. And I'm going to mute everybody. Actually, y'all mute yourselves because that way you can unmute if you need to and to ask a question. So let's do this. All right, let me know if you can't see my screen at this point. Why don't somebody tell me what doesn't belong in this particular warm-up? Does anybody actually know right off quickly? Go ahead, Charles.
J of x does not belong because 5x minus 2 does not have an x squared.
That's right. Excellent. Excellent. Good job, Charles. So I got me this little stylus. Let's see how well it works. Not very well. Yes, 5x minus 2 is not a quadratic equation. It is not squared in any way. So it would be a linear. It would look like a line, whereas all the other ones would look like parabolas. Excellent. Good job, Charles. All right. So next, what about, could we graph this function here? So let me go ahead and show you what, and this is a squared function. So what we learned last week is that our vertex formula was y is equal to ax minus h plus k. Well, our h in this particular formula, x squared plus 1, is actually 0. So x minus 0, I'm sorry, it's going to be x minus 0 is just x. And then this is a squared root here, which is it's not really working as well as I wanted it to. The a is just 1. So really, when you simplify all this down, this becomes x squared plus, and k is 1. Y is equal to x squared plus 1. If you haven't watched Keeper 28, you definitely need to watch it after this video. Watch them back to back, kind of like a Netflix binging. So if we look, our k tells us what we're doing on our y-axis, and in this particular point, we are shifting up 1. So our vertex is 0, 1. Okay, 0 because the h was 0. So we just shift up 1, and it would go right there. And then our a value is just 1, so it's up 1 over 1, up 1 over 1, up 1 over 1. And then on the other side, it's the same thing, up 1 over 1, up 1, or up 1, oops, sorry, it should be up 1 over 1, up 1 over 1, up 1 over 1. And if we could draw this, it would look something like that. It's very difficult to draw on here. Use your calculators if you would like, and it will graph it for you to verify that that looks just like that. So let's do Keeper 26. This is the vertex form equation, which I just drew for you. And h and k is our vertex. Now look, here's what you need to remember. The formula is x minus h. If you see x plus h, that means the h was actually a negative at one point. So two negatives make a positive. So if you see x minus h, always know that that's a positive h. If you see an x plus h, that actually is a negative h. So axis of symmetry is the h, okay? X equals h. And then a, we learned this yesterday as well. If a is greater than 0, the parabola opens up. If a is less than 0, it opens down. And we also know that a is our vertical stretch, or horizontal stretch and horizontal compression as well. So anything greater than 1, it stretches. Anything less than 1, between 0 and 1, it actually shrinks. So let's move along here so we can graph some of these. All right, I'm going to do one, and I'd like somebody to answer the other ones if they don't mind. So, excuse me, Corona's coming back. Here, this vertex is 4, 3. My h is negative, so that means it's actually positive. And my k value is 3, a positive 3. So if I was to graph this, I would go over to 4 and up to 3, and my vertex would be right there. All right, who would like to do 2? Can anybody tell me what the vertex for 2 is? Man, it feels just like class. Nobody's answering. Charles, you want to tell us what that is? Charles will have to unmute himself.
I don't know.
On number 2? Okay, let's go to Michael. Do you know what the vertex is on number 2?
Wouldn't the 1 be negative?
Yes.
And then the -5 would be the k coordinate.
That's right. So -1, -5. Good job, Michael. Nice work. That is right. Since it's a positive 1 here, it's actually written like this: x minus 1. 2 minuses actually turn into x plus 1. Good job. All right, number 3 is a little bit trickier. Mackenzie, do you know what number 3 is? Do you know the vertex on number 3? Mackenzie is not with us. Let me see. Caden, do you know the vertex on number 3? Oh, there's Mackenzie. Are you with us, Mackenzie?
Yes.
Okay. Do you happen to know the vertex for number 3?
0, 6 maybe.
Yes, 0, 6. Good job. 0, 6. See, this isn't hard. What about number 4? Who can do number 4? Caden, you got number 4 for us? Maybe I got a message here. No. Oh, I see. You're typing. I got it. Okay. Number 4. All right. Number 4, since there's no K value, it's going to be -7, comma, 0. I'm sorry, +7. See, you didn't correct me. It's actually a +7 there. Why does anybody know why it's a +7? I'll tell you why. Because x minus 7, the 7 was already positive. The formula is what tells us that it starts off as negative, but it would have to be x plus 7 for it to be a -7. So that is the equation, or that is the vertex, 7, 0, because there's no K value. So let's go through them once again. Number 1, the vertex is 4, 3, because I have a negative, it looks like a -4. It's actually a +4. The K value is 3. Number 2, since I have a +1 here, it's actually a -1 with a -5 for my Y, our K value. Number 3, there was no X value, so it's actually 0, 6, K value of 6. And here we have no K value on 4. All we have is an X value, and it's a +7 with 0 as the K value. Okay. So if we were to graph this, let's look at how we would do it. First, you determine if the parabola opens up or down. Well, in this case, since we have a negative right here, -3. Our parabola opens down. So it's going to open like this, okay? If it was a +3, it would open up. Who just signed on here? iPhone. Okay. Don't know who iPhone is. So step 2. Why ain't this working here? Step 2, compute and graph the vertex. In this case, we know the vertex. The vertex is going to be +2, 5. Okay. So our vertex is over 2 to the right on the x-axis and up 5 on the y-axis. So 1, 2, 3, 4, 5. We are right there. 2, 5. That's our vertex. And we know that it's going to open downwards, so it's going to come this way. It's going to somehow start coming over this way. Okay, next, create a table of values. And y'all done this. I remember doing this, teaching the kids at Garrett Middle School how to create a function table, as we called it. And you would choose from your vertex, you would choose 2 x values to the right, so you could use 3 and 4. And you would use 2 x values from the left, 1 and 2. So let's go ahead and create that table, okay? So this is going to be my table, a horribly looking table, but here's my x, here's my y. And I said we need to use 2. Let's go with 1, or 0 for our x, and 1 for our x. So if I input my 0 in for here, I'm going to get 0 minus 2, which is a -2. -2 squared is 4. 4 times a -3 is -12. And then -12 plus 5 is a negative, what is that, 7 or 8? 7. So 0 would be a -7. If I put 1 in here, I got 1 minus 2 is a -1. -1 squared is a +1. Times a -3 is a -3. -3 plus 5, -3 plus 5 is a +2. And that's a 2. So let's go ahead and plot those. If I go 0 and I go over down 7. 1, 2, 3, 4, 5, 6, 7. Let's make sure that's right. 0 minus 2 is a -2. -2 squared is 4. 4 times -3 is -12, plus 5 is a -7. Okay, and then 1, we're here at 1, and you go up to 2. So that's there and there. Now, if we do the opposite side, because we got to do 2 to the right, you're going to do 3 and 4. So 3 minus 2 is 1. 1 squared is 1 times -3 is -3, plus 5 is 2. And 4, I guarantee you, it should be 7. So we'll go over here and put 2 in. So if I go over 1, 2, 3 and go up 2, it's going to be here. And if we do 4, it should be 7 as well. 4 minus 2 is 2 squared is 4. 4 times -3 is -12. It's going to be -7. Okay. So go down to, hang on, I'll get right to you. So we're going to go over 4. And so our graph starts here and comes all the way down. Just like that. Okay, let me see who, we got some hands raised. Let's unmute. So whoever has their hand raised, you should, well, you have to unmute yourselves. Looks like y'all muted yourselves, which is fine. So go ahead if you have your hands raised. Anybody have a question?
No, I didn't mean to raise my hand.
Oh.
I'm confused on how you got -7.
Okay, how did I get -7 at the very beginning? Right here, you put a, we create a function table, right? And it says on step 3 here, it says create a table of values. Choose 2 x values to the right of the vertex and 2 values to the left. So the 2 values I chose to the left of my vertex, which was +2, 5, right, was 1 and 0. 1 and 0 was the numbers I chose. So if I put a 0 in for my x, that's going to give me x minus 2, which is -2, right? And then -2 squared would be a +4. And then 4 times a -3 is a -12. And then a -12 plus 5 is a -7. So you just create the numbers in your table, which we did here, put them back into your equation, your input values of x to determine what your y is going to be. Let's go to another one, and we'll do it again. And then we just plot the points and connect the dots. So this is not too difficult. The main part is find your vertex and create a table. So let's look at this one now. Same thing here. We need to find our vertex. Can somebody that's unmuted just tell me what the vertex is to begin with? Actually, step 1. Let's do step 1 in order. Step 1 is the parabola opening up or down?
Up.
Up. That's right. It's opening up because our value of 2 here is positive. So it's an up opening parabola. Step 2, what's my vertex?
-4, 2. -2.
Yes, -4. Who said that?
Tyler.
Good job, Tyler. -4, -2. Thank you. Okay, step 3. Let's create our function table. So maybe I can do this a little bit better now. X and Y. Okay, so we need 2 to the right and 2 to the left. So if we're at -4, 1, 2, 3, 4, and down 1, 2, so we're right here. So I could have -5 and -6. That's to the left, but whatever. -5, -6, and then over here I could have -2, 3, and -2. Okay, that'll give me enough points there. That's a 3. Sorry, 3. Oh gosh, 3. All right, whatever. So if I input these x values in for this equation, I'm going to get this y value in return. So if I say -5 plus 4, that's going to be a -1. -1 squared is 1. 1 times 2 is 2. 2 minus 2 is 0. Now 6. 6 in for my x. 6 plus negative 6 plus 4 is a negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 2 is a positive 6. Okay. As long as I'm doing the math correct, that would be. Let's see. Negative 3. Negative 3 now for my x. Negative 3 plus 4 is a positive 1. Positive 1 squared is 1. 1 times 2 is 2. 2 minus 2 is 0. And I guarantee you that negative 2 should be 6. But let's see. Negative 2 plus 4 is a positive 2. 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6. All right, so let's plot those now. We got our vertex here, and then from the vertex is where you have to use your points, okay? So let's see. X is a negative 5, so let's go over to 5. Negative 1, 2, 3, 4, 5, 0. So it's just going to stay right there. And then 6 all the way up, negative 6, I'm going to go all the way up to 6. 1, 2, 3, 4, 5, 6, all the way over to 6. So I'm going to be right there. Okay, that's good enough. Negative 3 is 0. So go over 1, 2, 3. Negative 3, 0. And then from here, I go all the way up to 6, which is here and here. Oh, I wish this would write better. And then I just graph it. And here's how you can check yourself, because I always like math. I can check myself if I need to. Let's see if I go up 2 over 1, because that's also my slope. My A value is my slope. So up to 1, 2 over 1. Yes, that works. Up to 1, 2 over 1. I get back on my line. Up to 1, 2 over 1. I'm right here. So it does work. So yes, we are correct. So that's it. We just graphed that parabola. Oh, I didn't know that there was other things. It opens up. The vertex is negative 4, negative 2. Our axis of symmetry. We learned that last week. Comes straight through the 4, the negative 4 here. Okay, axis of symmetry would be a negative 4. It's what separates the parabola into 2 equal halves. Okay, the axis of symmetry is always the x value. Okay, it is always the x value for the vertex. Okay, so it's always your h variable. The domain. Who remembers domain and range? Domain is all of your possible x values. So remember that?
Yeah.
Okay, good. So what is our domain there? It's all real numbers, right?
Yeah.
And what's our range? It's all possible y values. Remember? Well, here at the y value, it's negative 2 is less than or equal to, right? Y, which is less than or equal to infinity, positive infinity. Okay, so everybody get that? I'll give you a second to make sure you understand how we got that. Let me know if you have questions. Okay, I'll go to the next one. We're going to do the same thing here. Do I have any? Let's just go through it with step 1. Who can tell me what is this graph doing? Let's make sure. We'll just do this. What is the graph doing here? How does it open?
Down.
Down. Thank you. Down. The graph opening down because we have a negative value there. Can somebody tell me the vertex?
2, negative 3.
2, negative 3. Excellent. Okay. What's the axis of symmetry?
2.
2. Yes. And the interval of increase? Does anybody know that? No, we don't know that because we need to plot that. We have an interval of increase and interval of decrease. Does anybody remember what intervals are. If x approaches something, what is y approaching? Remember that?
Yeah.
Who is talking?
Caden.
Well, thank you, Caden. I appreciate you being part of this group. Where is everybody at? I know it's Monday, guys, but come on. It's math. This is fun.
We're here.
We're here.
Yeah.
All
I'm
right.
just tired.
Just listening.
All right. So let me go ahead and plot this. So I got 2 comma -3. So I go over to 2 on my x-axis, which is here, and I go down 3. 1, 2, 3. So that is my vertex. That is also my axis of symmetry is right through the vertex. So it's right there. Now we can make us a little table. Boop, boop, boop. Okay. So my x values, x, y. What, bud? Oh, you found it. Good. Sorry. My youngest walked in. All right. Hey, bud, you want to come say hi? Say it real loud. Huh? It's my students. Just say hi real loud. Hey, Hudson's on here. Remember meeting Hudson? Yeah. All right. Well, tell him math is fun. Oh, you don't want to say math is fun? Okay.
He knows math isn't fun.
do math at school.
You do math at school. Good job. All right. So let me go ahead and put these numbers in here. So we know we need 2 to the right and 2 to the left. So we'll just use 0 and 1 again. Those are always easy. And we'll use 3 and 4. 3 and 4. Oh my gosh. I don't know why I cannot write a 3. Save my life. So if I put a 0 in for my x, I'll get -2. -2 squared is 4. 4 times a -½ is a -2. -2 minus 3 is a -5. Would y'all agree? -5. All right. Now I've got 1. 1 minus 2 is -1 squared is 1. 1 times a -½ is a -1/2. Oh no, we're gonna have a fraction here. All right, so that's not gonna be good. So 1 minus 2 is a -1. -1 squared is 1. 1 -1/2 times 1 is a -1/2. -1/2 times 3. What's a -1/2 times 3, class? Anybody know? I got my calculator here because I don't really know either unless I use my calculator. Let me see. 0.5 negative minus. Oh, it's -3, not times 3. I got a -3.5 or 3.5. 3.
Yeah.
3. Oh my gosh. Anyway, y'all know that's -3.5 right there. -3.5. Okay. Now if we put a 3 in, 3 minus 2 is 1. 1 squared is 1. 1 times -1/2 is -1/2. -1/2. There we go again. We got a -3. Or a +3.5 this time. No, it should be a negative as well. Okay, and 4 times -2 is 2 squared. 4 be a -1. Again, we are going to have, let me just make sure. 2 minus 3 is 5. Okay, we got our points. Nothing is writing here. 4, -5. Okay, so we plot them. Let's see, 0, 5. So it's -5. Well, that I don't know what just happened there. 0, -5. So that we know it opens down. That's good. So 1, 2, 3, 4, 5. 0, -5, which is right here. Why is this so hard to write on? Now we have to go 1, negative 3.5 over 1, and then down to 3, and then 0.5. We're somewhere like right there, and right there. And then the same thing over here. We're about right there, and approximately 5 here. So our graph is doing this, something like that. It's hard to write on this little thing. So what is our interval of increase? As x approaches positive infinity. So as x approaches positive infinity, y is approaching negative infinity. As x approaches negative infinity, okay, y approaches negative infinity. Does everybody see that? Any questions? So as x approaches positive infinity, wrong way, Stephen. Positive infinity, comma, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity. Okay, there we go. All right, how many more do we have here? All right, I'll do this last one here so we can finish up. And then you have the worksheet that's on Schoology, and I'll also post, since there isn't one, I will post on my blog site, I will post the answer key to that. So for this particular example, y equals 3/2 x squared plus 1. We know that since there's no negative sign, it's going to open upwards. Our vertex is 0, 1. Our axis of symmetry is 0. Now we're looking for a min-max value and our end behavior. Okay. Well, we know what our minimum value is. It's 0. And our max value is going to be infinity since it opens up. And our end behavior. I think I messed up back on this one, talking about this interval of increase, interval of decrease. Yes, that's end behavior. This is end behavior. Yes, that's end behavior. Interval of increase is over here. Remember, it separates here in between the axis of symmetry. And so the end behavior is us always approaching real numbers. Interval of increase, there is no interval of increase. It's always an interval of decrease. There is no interval of increase. It's not increasing anywhere. It's always interval of decrease because it's going down the y-axis. All right, back to this one. Opens up, our vertex is 0, 1, our axis of symmetry is 0. Let's graph it. Okay. So we got to create a chart. Our x and our y. Okay. So we got to, for our x, we're going to do -1, -2. And then for our other one, we're going to do 1 and 2. So we're going to get the same exact value. So if I put a -1 in here, -1 squared is just 1. That'd be 3/2 plus 1. So that'd be 2/2. I'll write a little bit bigger out here. 2/2 for our y. -2 squared is 4. 3 divided by 2 times 4 plus 1 is 7. So -2 is 7. And the same thing for here. For 1 and 2, you're going to get 2/2 and 7. As you can see, since it's a parabola, it mirrors each other along the axis of symmetry. All right, so here's our vertex. It did shift up 1, So we have 0, 1, which is right here. And then we go over -1, we go up 2 halves. So we're over to -1 and up 2 halves. 1, 2, and then it's going to be right in the center there. All right, and then we go over to -2 and go over 7. So we're going to go all the way up to 7. 1, 2, 3, 4, 5, 6, 7. We're right there. This thing does not work well. 2 halves is right there. Same thing here. Go up over here and then up over here. And our parabola looks like this. All right, we already know what our min value is 0. 0, 1. Our max value is infinity. And our end behavior as x approaches positive infinity, y approaches positive infinity. As x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches positive infinity. Let me know if you have any questions regarding that. If not, I'll give you a few minutes to decide. But other than that, we're done for the day. I will go ahead. All right. Well, if there's no questions, I will post this to our blog. Also, do the worksheet. You will on Thursday. You will have a USA test prep assignment. I've already created it. It'll open up on Thursday, and that will be due Friday. I think it's only 10 questions, so it's not too difficult. I think it's 10. It may be more, but I believe it's just 10 questions. And that will be a grade that I'll have graded on USA Test Prep, and we'll see how that works on the way coming back. But appreciate everybody that turned in your odd numbers on your review assignment. If anybody had questions about any of those on the review assignment, we've got a few more minutes. If nobody has questions regarding it, you can drop off. But if others have questions about it and still need a little bit of help, let me know and we can stay on for a few more minutes. Other than that, y'all have a good rest of your week, and I'll see you tomorrow.
Thank you.
Thank you.
So,
Yes, ma'am.
yeah. So for points, do we just pick like any point at all?
No, you can't. You have to pick whatever you find the vertex, Annie. When they find the vertex, you have to pick 2 points to the left and 2 points to the right of that vertex. So it'll always be right here on number 3 here. You see where it says create a table of values?
Yeah.
To choose two x values to the right of the vertex and 2 x values to the left of the vertex.
Okay. And then we plug them into the equation to find the other point.
The y
point.
That's right. Yep.
Okay.
And then graph
Alright.
from there. So this is not very difficult for you guys. I figured this would be more of a re-lesson into graphing than a new lesson.
Okay. All right. Thank you.
Yes, you're welcome. You have a good rest of your week.
You too.
All right. Bye-bye.
Bye.